Hello, and welcome. Today we begin our exploration of a fundamental concept in fabrication, weldability. But what exactly does this term mean? It is far more than just the ability to melt two pieces of metal together. Weldability defines the ease with which a material can be successfully joined to form a structure that performs reliably in service. It is a complex interplay between the base metal's properties, the chosen welding process, and the procedural techniques we employ. Over this session, we will unpack these critical interactions and how they determine the success or failure of a welded joint. Understanding weldability is the first step toward mastering quality welding. The capacity of a metal to be welded under the fabrication conditions imposed into a specific, suitably designed structure and to perform satisfactorily in the intended service. Weldability defines the ease with which steel can be welded into a sound, defect-free joint. Primarily influenced by composition, low-carbon steels possess excellent weldability. Higher carbon and alloy content, example, chromium, molybdenum, increase hardness and the risk of cracking. For these steels, specific measures like preheating, controlled heat input, and post-weld heat treatment are often essential to manage microstructural changes and residual stresses, ensuring joint integrity and performance. The Liberty Ship tragedy is a seminal event in engineering history. Mass-produced in World War II with innovative welded hulls, these vessels were vital for Allied logistics. However, the steel used was susceptible to brittle fracture in cold North Atlantic waters. Sharp square hatch corners acted as stress concentrators, initiating cracks that could propagate rapidly through the continuous welds. Over 1,200 ships suffered cracks, and several catastrophically split in half and sank. These failures prompted extensive research, revolutionizing understanding of fracture mechanics. The tragedy led to mandatory Charpy V-notch testing to ensure steel toughness, the redesign of components to avoid stress concentrations, and the development of fracture-resistant welding practices, profoundly improving structural integrity across all engineering fields. What is weldability? Weldability is the ease with which a material or materials can be welded to give an acceptable joint. Ability of a material to be welded by most of the common welding processes. Define as: retain the properties for which it has been designed. Weldability defines a material's capacity to be welded into a specific structure under a defined procedure, achieving required service performance. It is not an innate property, but a measure of how easily a sound, crack-free weld can be made without defects. Key factors include the material's composition, especially carbon content, its tendency to harden, and the chosen process. Good weldability means the joint retains mechanical properties, such as strength and toughness, similar to the base metal. Poor weldability necessitates complex procedures, like preheating, to avoid failures. That's all for this video. Make sure you will continue with the next videos. It will continue with the same topics, weldability. Stay tuned.